Title: Outdoor Elevator vs Indoor Elevator. Which is better for your building? Hook when planning an elevator project. Many building owners ask one question first: should the elevator be installed outdoors or indoors? It sounds like a simple choice. Outdoor means outside the building. Indoor means inside the building. But in real projects, the answer is rarely that simple. The better choice depends on building layout, available interior space, retrofit difficulty, environmental exposure, corrosion risk, maintenance expectations, and long-term life cycle cost. An outdoor elevator can be a practical solution for existing buildings with limited indoor space. An indoor elevator can offer better environmental protection and smoother architectural integration. So the real question is not only where the elevator should be installed. The real question is, which solution fits the building's actual conditions better? What is an outdoor elevator? An outdoor elevator, also called an exterior elevator, external elevator, outdoor lift, or outdoor lift system, is installed outside the main building envelope. It is commonly used in outdoor home elevator projects, outdoor passenger elevator systems, accessibility lift projects, commercial retrofits, hillside homes, public access facilities, and transportation infrastructure. One major advantage of an outdoor elevator is that it can often be added to an existing building without major interior reconstruction. For example, if a building has limited interior space, narrow stairwells, or layouts that are difficult to modify, an exterior elevator shaft may provide a more practical access solution. But an outdoor elevator is not simply an indoor elevator placed outside. It must operate in an exposed environment. That means it needs weather protection, corrosion resistant components, proper drainage, sealed electrical protection, and material choices suitable for the local climate. What is an indoor elevator? An indoor elevator, also called an interior elevator, internal lift, elevator inside a building, or residential indoor elevator, is installed within the protected structure of the building because it operates inside the building envelope. It is usually protected from rain, snow, humidity, direct ultraviolet exposure, airborne pollutants, and large temperature changes. Indoor elevators are common in residential properties, hotels, office buildings, healthcare facilities, shopping centers, and mixed-use developments. For new construction, indoor elevators are often preferred because the shaft structure, lobby, and interior design can be planned together from the beginning. This gives better architectural integration and more predictable operating conditions. The limitation is that an indoor elevator requires dedicated space inside the building. In retrofit projects, that may mean floor openings, structural changes, utility relocation, or changes to the existing layout. Installation and space differences. One of the biggest reasons owners choose outdoor elevators is installation flexibility. An outdoor elevator can often use an independent exterior shaft attached to the building. This can reduce interior demolition and preserve usable floor area. That is especially useful for older buildings, historic properties, accessibility upgrades, small homes, and buildings where indoor shaft space is not available. An indoor elevator usually requires a dedicated shaft inside the building. For new construction, that is not a major problem because the elevator can be included in the design from the beginning. But for existing buildings, creating an indoor shaft may be much more complex. So from a space and retrofit perspective, outdoor elevators often have an advantage, but that advantage comes with environmental responsibility. Weather exposure is the biggest difference. The biggest difference between outdoor and indoor elevators is environmental exposure. An indoor elevator works in a relatively stable environment. An outdoor elevator may face rain, snow, humidity, wind, ultraviolet, radiation, salt spray, industrial pollution, and temperature fluctuations. These conditions affect material selection, maintenance frequency, service life, and total operating cost. This is why outdoor elevators require more careful life cycle planning. A properly designed weatherproof elevator can perform reliably for many years, but the design must match the environment. A mild rural outdoor installation is very different from a coastal elevator near the ocean. A city installation with light pollution is very different from an industrial or marine environment. Corrosion risk and CFA to CFA environments. Corrosion is one of the most important issues in outdoor elevator planning. Not all outdoor environments have the same corrosion risk. A dry indoor environment may be similar to a CFA corrosion environment, which is very low risk. A rural outdoor area may be closer to CFA, with relatively low corrosion risk. Urban areas, light industrial zones, and moderate coastal exposure may fall into CFA. Industrial districts, chemical processing areas, and high humidity environments may reach CFA ports. Marine facilities, offshore environments, and heavy industrial areas may reach CFA, where corrosion risk is very high. This matters because an outdoor elevator in a CFA environment does not need the same protection strategy as an outdoor elevator in a CFA marine environment. For coastal projects, salt-laden air can accelerate corrosion on steel structures, fasteners, guide rails, electrical enclosures, and exposed hardware. In these cases, designers may need stainless steel components, corrosion-resistant hardware, enhanced protective coatings, sealed electrical enclosures, improved drainage, and higher IP-rated control equipment. Indoor elevators usually avoid most of these exposure risks because they operate inside the building envelope. Steel shaft versus aluminum shaft. Outdoor elevator shaft material also matters. Steel shafts are common in outdoor passenger elevators and commercial outdoor lift systems. Steel provides high structural strength, strong load-bearing capacity, and flexibility for taller installations. But steel must be protected properly through galvanizing, coatings, or stainless steel construction. Without effective corrosion protection, rust can become a long-term maintenance issue. Aluminum shafts are often attractive for outdoor home elevator projects. Aluminum is lightweight, naturally corrosion resistant, lower maintenance in many environments, and visually modern. But aluminum is not automatically the right choice for every project. Building height, structural load, Local weather exposure, budget, and long-term maintenance strategy all need to be evaluated. The best shaft material depends on the project, not the material name alone. Maintenance and life cycle cost. Another common misunderstanding is that outdoor elevators always require excessive maintenance. That is not always true. A properly designed outdoor elevator with weatherproof enclosures, corrosion-resistant materials, effective drainage, sealed electrical protection, and regular preventive maintenance can deliver stable long-term performance. However, outdoor elevators usually require more environmental inspections than indoor elevators. Maintenance may include corrosion checks, coating inspections, seal inspections, drainage system checks, guide rail cleaning, fastener inspections, electrical enclosure inspections, and lubrication verification. Installations in CFA or CFA environments may need more frequent inspection than elevators in mild CFA or CFA environments. Indoor elevators generally have lower environmental maintenance pressure because they are protected from weather exposure. But both indoor and outdoor elevators still require routine maintenance for safe and reliable operation. The better decision should not be based only on initial installation price. It should consider life cycle cost, environmental exposure, maintenance consistency, material quality, and installation quality. How to choose an outdoor elevator may be better if the building already exists. Interior space is limited. Major interior renovation is undesirable. Accessibility upgrades are required, or external access between levels is needed. An indoor elevator may be better if the building is being newly planned. Architectural integration is a priority, environmental exposure is severe, lower maintenance pressure is preferred, and enough interior shaft space is available, so the choice is not universal. Outdoor elevators solve space and retrofit problems, but they require stronger environmental protection. Indoor elevators offer better environmental stability and architectural integration, but they require usable indoor space and more building coordination. Conclusion: outdoor elevator versus indoor elevator is not just a location decision. It is an engineering and lifecycle decision. Building layout, available interior space, retrofit complexity, weather exposure, corrosion environment, shaft material, maintenance access, and long-term operating cost all matter. For more details, you can read the full article here. https://facnalift.com. Elevator. Thus indoor elevator